Hello, everyone. Welcome to another episode of AWS Show and Tell. I'm your host, Anil Nadiminti. I'm joining from New Jersey today. And, I'm as an introduction, I am a solutions architect here at AWS supporting enterprise customers in the fintech space, working with cryptocurrency customers, right? So, and we have other members on the wider team joining us today, the specialist team. So we'll go through the introductions and then we'll look at the topic, right? So over to you, Josh.
Hey everyone, I'm Josh. I'm a solutions architect here in our financial services group as well. I work with Neil.
Hey, Madhu.
Hello, everyone. I'm a worldwide specialist solution architect focusing on agentic AI at AWS. Nice to have you all here.
Thanks, Chetan.
Yeah, hi everyone. Nice to be here. I'm a principal product manager in the AWS AgentCore team. I'm focused on AgentCore payments. Nice to be here.
Cool. Yeah. So at this point, we've been doing a number of episodes on bringing AgentCore content, building, how to build your agents from POC, get them into production, and we've spoken. We've had many episodes going into the details of observability as well. Right? Madhu has joined us on a few episodes at this point, right? So, but today's content is different, right? So we want to talk about how agents can transact and how agents can make payments, and that's one of the next steps in the evolution of agents. So that's why we have this cool team here talking to us about AgentCore payments as well, right? So maybe why don't we go through some introduction on that topic and then get going.
Yeah. So maybe I'll talk about first on why did we come up with this AgentCore payments? Like, what is the thinking behind coming up with this whole thing, right? So there are two aspects which we looked at. I think the first aspect is how are agents evolving, right? Like in the beginning, we saw a simple chatbot kind of applications where people were asking questions and getting answers. It couldn't really take actions. Then there is second stage of agents, right, which are more, it could plan, it could reason, and it could also call APIs, but it was generally for a narrow task, and it was not very complex in nature, and it required a human in the loop. So that was the second evolution of agents. Now, lately, what we are seeing is the agents are becoming more and more capable. We are moving into multi-agent kind of a system, and they're becoming autonomous and long-running in nature, right? So they can plan, reason, they can run for a long time, and they can take autonomous decision on behalf of humans. So that's what we have seen lately. So that's one evolution which you're seeing on one side. And of course, like one of the core things which agents do is actually accessing tools. And these tools, by tools, we mean it could be an API, it could be an MCP server, and some of the browser agents can also access content on the websites, right? So web content. So these are all tools, and it's a very core element of an agent. So we'll just have a look at like what's happening on that side. That's on the other aspect of evolution which is happening. So tools, typically earlier, what is to happen is if an agent developer is trying to, from an enterprise wants to access a tool, they will have to kind of go to that service provider, come up with a subscription with them, register with them, and get API keys, etc. So it was a human in the loop kind of a process. Now, in this agentic world where agents are becoming more and more autonomous, and we are seeing this rise of agentic traffic, even the service providers are kind of adjusting to this agentic world. Say if one of the core examples which you can see is a lot of websites hosted on CDNs, they're blocking agentic traffic, right? And they're monetizing that agentic traffic on a pay-per-use kind of a model. So those are some of the trends which you're seeing, which is happening in this space. So the future which we see is there will be proliferation of agents. There'll be billions of agents accessing n number of tools, APIs, MCP servers, and web content hosted on websites. And this will be generally autonomous in nature, and also these tools which they are monetizing for this agentic traffic, they're generally small value transactions. Like say, for example, those tools, like if you want to access an API, it'd be a few cents or $1 transaction. So that's the trend we are seeing on the supply side, on the tool side, on how evolution is happening.
And that's what's all these products that folks are building, right? These websites, as you said, Chetan, there's too many bots out there, and too much traffic. there are scrapers that are hitting API endpoints, websites that are being scraped. You want to really figure out, where you want to allow the traffic and where you want to block it, or you maybe want to monetize on the traffic, right? So that's the evolution that we're seeing.
Yeah, just building on top of what we kind of discussed in the previous slide. So agents are, as we discussed, becoming more and more autonomous. So they have a goal to achieve, and as part of the goal, they want to access multiple APIs, data, content, MCP servers, etc., autonomously, right? Or even accessing databases, etc. So the real challenge comes when these endpoints are paid, right? Like in that time, these autonomous agents, for achieving a goal, it gets stuck. It doesn't have that ability to make that payment to move forward and complete that task. And that's what we are trying to kind of see, like how we can solve. So if you have to do this traditionally for your agentic workflows, you need to kind of go to like an enterprise agent developer will have to go to each service provider, register or come to a subscription, get their API credentials, manage that API credentials manually. And also, end of the billing cycle, they need to have like a billing relationship, each of the service providers. Now imagine for an agentic application, I have like 20 different services which I need to access for completing my task. Then that means like this complexity just compounds, not like increases linearly, right? So it becomes very complex. Additionally, if you have to like implement payments to your agentic workflow, you also need to think about, given these agents are autonomous, how do we put guardrails? Like it doesn't cross a particular threshold, right? There is no runaway spending. Also, like there are multiple protocols going on, like, agent developer have to really worry about which protocol I have to build. I have to repeat the work for every protocol depending on the endpoint I'm using. So all this is like, incremental work for every new complexity which you're kind of dealing with. And also, since it is payments, you want to have some kind of observability of like, where exactly the agent is going and making the payment, how much is the value of the payment, etc. Right? So building all this takes like months of effort. It is like pretty complex. It's not scalable in nature. And what we hear from developers is the following, right? When we spoke to all these developers or customers, can I get one solution which kind of does this end to end and like, removes all this complexity and the effort which is required? Also, there is additional risk, right? Risk of agent going and doing that runaway spending, right? Without any guardrails. Also, given this is payments, it's a very sensitive topic. So you don't want some of the things to be leaked. Like say, for example, your payment instrument, credit card details. So the level of security and guardrails is much higher for these kind of applications because there is payment involved. And the risk is not just agent going and taking a wrong decision. It is actually money moving from one place to another, right? So the level of, the risk is much higher in this case.
And yeah, right. So when we allow the agents to transact and we give our credit card details, right, to the agents or any secure payment information, how do we know that it's not getting stuck in these LLM loops, observability loops, right? So those are all the things that come to mind.
Yes.
And agents by nature are non-deterministic, right? So we want to make sure that when payments are involved, we want to have more control on those payment rails and how we can transact securely. Maybe those are the things that definitely come to mind.
So when we spoke to developers, I mean, these are the things which they said like we need like one solution which kind of solves for all this. Like when I think from a developer perspective, like first thing you need to figure out like how do I fund my agent? Like there are wallets, like how do I connect very securely to like a wallet which has those funds, right, for making those agentic transactions? Like how do I control the agent behavior? Like how do I give explicit permissions saying that do these things, don't do these things? And also like having some kind of a payment limit capability where I can set a budget and agent doesn't go and spend beyond that. It kind of deterministically enforces that budget. Also, as I said, like there are so many protocols out there. Like I don't want to pick a protocol. Like you figure out how like which protocol to use depending on the use case or the endpoint, right? And abstract that complexity out of me, right? And of course, the observability is something which we discussed. You want to have full details on where the agent is going and spending, how much amount it's being spending, and all some kind of metrics on like what's the failure rate, etc. It's all I want to kind of hear. So developers have been telling us, can we get like one common solution we can solve this end to end? And that is the reason why we kind of launched AgentCore payments. So this is a new capability or a feature within the AgentCore platform, which we launched on preview on 7th of May, which was like around 3 weeks back. And we did this in partnership with Coinbase and Stripe, which enables AI agents to make this transactions or payments for paid APIs, paid MCP servers, paid web content with just a few lines of code and within few minutes, right? So make it super simple and easy for developers to kind of enable payments for their agents. And it's in the same platform, AgentCore platform, where already you have built agents. You're using runtime for your hosting that agents. You have your policy setup. You have your identity. Now you have an additional capability of adding payments to that same agent with all the security, governance, guardrails which you already have in AgentCore platform. So that's what we have built and launched.
And we've also been, as part of this enablement series, Madhu, you've joined some of these conversations. The whole premise of AgentCore is that we can, bring any model, host it on runtime, and maybe can you talk about that aspect of it, like how that all fits into this bigger scheme of, bring your model, bring your framework, deploy it, right?
Absolutely. Extending to that, AgentCore has always been committed to open standards and open source protocols, which means that all of these features available within payments, you're able to build agents with any of the popular open source frameworks, choose any of the model, and extend the capabilities of agents that can transact with the capabilities of AgentCore wider and beyond, which means purpose-built infrastructure or runtime, adding memory capabilities, controlling behavior using policies, and a lot more.
Right. So, and Chetan, you mentioned this is a managed service, right?
The managed service, which is a new service in AgentCore platform. Yeah.
Nice.
Yeah. So what we'll do is we'll go to each of those aspects in detail. But before that, I want to just ground the people who are listening in terms of different personas, so it'll be easy for us to follow in the subsequent sections. So there are three personas. One is the agent developer who is building that agent and wants to access like a paid resource or an endpoint. And the second one is like the user of the agent, right? Like say, for example, I'm building a deep research agent. I have my end users accessing my agent, which I built. So that's the user. And I'm using like a paid endpoint. It could be like a web content. It could be a paid API content or like an MCP server. So that is offered by third-party services, like we call them merchants. So these are the three personas we are talking about. And before we go and deep dive into each of the sections, we want to kind of start with the demo. So this is like an end-to-end use case to show like what's the art of the possible. And this is one of the use cases, popular use cases which our customers have been trying when they're trying building on AgentCore payments. So here, this is a research agent, deep research agent. So the deep research agent, an end user comes and tries to do a deep research task, and the agent, to finish that task, it has to basically access premium data, right? Like it could be real-time market data, analyst sentiment, or financial reports, etc., to complete that task. So in this demo, you will see how the agent autonomously goes and negotiates. Okay, these are the endpoints I need. Understands okay, what's the price point? Accesses the wallet very securely and makes that payment, all while maintaining guardrails. Like if you set a budget, it kind of enforces that very deterministically. So you'll see all that. All that in this demo. And under the hood, we are using, we have built it in a very protocol agnostic way. For preview, we support this protocol called as X402 protocol, which is a very popular protocol for machine-to-machine payments. And that's how it goes and makes that negotiation with the endpoint and makes that payment. So I'll quickly play this video and walk you through it.
So maybe as it's playing, right? So maybe I see that you're setting a budget there in the top.
Yeah, so the budget is $5, and now you said like I want to analyze Amazon stock performance, and it kind of lists all the endpoints. So if you can see that there is like real-time price data, etc., and a lot of these are paid endpoints, right? Like analyst sentiment, etc. So it goes and fetches that paid endpoint. It makes a payment, which is like few cents of dollars. And it kind of completes this deep research analysis, right? By dynamically, autonomously understanding what the endpoints, what's the price for each of the endpoints, and making like an autonomous payment to access the data from that endpoint and complete the research task. As you can see on the top, the session budget has reduced depending on how much money it has spent, from $5. Now we are going to update the budget to like 3 cents and trying it out. Like what does the agent do now?
So what happens when an agent exceeds the budget, right? Like, is it the LLM that's controlling the budget, or how are we doing this?
Yeah, so that's the beauty of AgentCore payments. So we have this as feature as called payment limits. So with payment limits, we kind of deterministically determine when we are running out of budget, and we stop that execution, right? In this case, if you see that the budget provided was not enough and the price of the endpoint was higher than the budget, so it kind of didn't even go and execute it. It at the infra layer, it kind of stopped and enforced that budget in the runtime.
So at the beginning, when you showed this, it's going out. It seems like the agent has the ability to sort of navigate a variety of endpoints and make its own sort of autonomous decisions around what's within its budget, what it should do, and then when it comes back, maybe how to format those results. So it's kind of, you can rely on the intelligence of the agent, but give it this new freedom to transact, this new capability.
And that's exactly what we're unlocking for the developers, because now the developers can focus on the performance on the agents and the payment infrastructure is fully managed.
Totally.
So if I were a developer, right? So again, let's say that we are talking about market data, and I'm interested only in the stock data for Amazon for a single day. So does this protocol unlock? Does this whole product protocol unlock me to grab the content for Amazon for a single day? For example, right? If somebody's hosting that service, is that how it works?
Yeah. So it basically we also offer ready-to-use endpoints, right, which are supported on a pay-per-use basis on an X402 protocol. So the developer can go and explore, okay, what are the endpoints, and if there is a relevant endpoint which can give this real-time data for a particular stock and kind of access that and use that for their use case if they were trying to do research, etc. So that's totally doable. So it's like a direct HTTP call. The only thing additional added layer here is the payment, right? You get a response, this was the amount you need to pay, and the agent goes and autonomously goes and makes that payment using AgentCore payments.
Right. So makes sense, right? So bigger picture is you don't need to have a subscription model there. So with this X402, you only pay for what you want and you consume what you want.
Yeah. Okay, cool. Let's move on. Let's deep dive into each of the sections, which we kind of called out earlier. So let me go to the next slide. Yeah.
Awesome. Thank you, Chetan. And I see if this is the first ever time you're seeing a demo of an agent transacting, I think a lot of questions come up in your mind. And throughout this next section, what we aim to do is address those questions that are coming up in your mind. And if agentic commerce is really in its inception, and it is truly such an exciting space. But developers face a lot of challenges, as Chetan identified, of wiring these different third-party wallets. How do I trust an agent making payments, and how do I manage these protocols that are going on, right? So to start with, to make a payment, you need to fund the agent, right? Like that's where we all begin. So how do we really fund the agent, and what makes this possible? So with AgentCore payments and the wider AgentCore, what we are building is a comprehensive suite of platform services that offer purpose-built infrastructure for agentic workloads at scale. AgentCore payments was built to address these developer complexities to provide instant payments to paid external resources. This could be APIs, tools, etc., with stablecoin support for cost-effective microtransactions. Microtransactions are sub-cent transactions that make this whole ecosystem economically viable. So an agent that has access to a wallet is able to make this payment autonomously with external payment providers. In public preview, we're launching with Coinbase CDP wallets and Stripe Privy wallets with these integrations. But the end user with access to this wallets is really able to fund the wallet with any fiat rails. It could be credit card, Apple Pay, or a USDC stablecoin on blockchain, etc. So once you've funded the wallet and given this wallet's access to an agent, let's now dive deep into the aspects of AgentCore payment concepts that make this microtransaction possible. In AgentCore payments, we have different core components that connect all of these payments, agents, and paid resources together. To start with, what's the real payment resource that sits in your AWS account that an agent developer has access to is what the top level resource is, the payment manager. This is what you create in your AWS account to coordinate the payment operations across your AI agents. And when you create a payment manager, AgentCore Payments provisions a corresponding workload identity in AgentCore Identity. And if you've checked out the deep dive on AgentCore Identity, you already know what that means. And you can create separate payment managers for different agent applications, different environment in staging, production, development, etc., and manage at these top level resource. Within the payment manager, which external wallet provider really holds the money is the payment connector. What payment connector does is it integrates your payment manager with an external payment provider, and each payment connector references a credential provider that stores these credentials within AgentCore Identity, ensuring that these sensitive credentials associated with these payment providers are never directly passed to the payment APIs. So a payment connector belongs to exactly one payment manager, and a single payment manager can have multiple payment connectors, which is what AgentCore Payments was built with, to be wallet agnostic. You can choose to swap in and swap out your wallets for your different workloads based on your use cases. And where are these API credentials really being stored of these external wallet providers is within this payment credential provider. It is a specialized credential provider designed for payment protocols, which securely stores these vendor-specific credentials and wallet secrets and authorization IDs in AWS Secrets Manager. And a payment instrument is whose specific wallet address is this transaction drawing from is what the payment instrument answers. It represents an embedded crypto wallet that the agent is using to pay the merchants on behalf of a user. So we have all these goodness within the managed service and a lot of control and data plane APIs. But the real question when giving an agent the ability to transact is a critical hurdle for the developers on figuring out how to do this entire process securely. Because money is at stake, it's not just a plumbing problem, it is also essential that we handle it in a secure fashion. Since AgentCore Payments sits within the wider comprehensive platform of AgentCore, it leverages AgentCore Identity, and when developers create these payment connectors, it integrates with AgentCore Identity, which automatically provisions a credential provider and stores these in a secure token vault and mints tokenized access without ever exposing the raw credentials. On the inbound side, you're able to leverage dual authentication on OAuth and SigB4. And if you're familiar with this already, the same request pipeline for accessing AgentCore Payments API provides a flexible security layer, which means that for OAuth type of invocations, the inbound bearer token is validated against AgentCore Identity, and the JOT claims are extracted to derive the user identity. For AWS SigB4, you can even leverage IAM conditions. Through this way, you're able to securely separate the infrastructure that executes the payments, store the credentials securely, and access the external payment providers independently. And this is what makes it possible. So, Joshua, we're learning about all these different concepts. Why don't we just take a look at how do we really get started?
Yeah, for sure. So I'll pull up my console here. And I'm going to start out here in the root of the Amazon Bedrock AgentCore console. And over on the left, you see all the capabilities of AgentCore. And there's lots of descriptions of those capabilities below. And so I'm going to go into payments here, which is in preview, indicated. And then when you land on the payments page, it's going to show you how it works and guide you through some of what you were just talking about. So first, we have to create a payment manager with connectors. So we set up payment manager and we add one or more connectors. So we go in to create payment manager, and we can leave it for now with the default name of payment manager, but we might want to customize this if we have multiple payment managers for coordination. And then we can actually create the new connector right here during the manager setup, or we can create payment manager and then come back and create the connector later. So I'll go ahead and create a new connector here. And just to show you the workflow here, we can call this whatever connector we want, but then we have a choice of provider. So as we mentioned, our partners here with Coinbase or Stripe. So if we go to Coinbase, we have the configuration is an API key ID and secret, and then a wallet secret used to authenticate your operations for the wallets. We can also choose privy, and then it's similar. We have app ID and app secret, but then we have the authorization ID for the entity on privy, and then the private key used to sign requests. So we can set that up here, and then once that's set up, we can go ahead and create the payment manager.
So which means that the secrets that we're using to authenticate with the wallet can be stored securely using the mechanism that we've shared in the slide earlier.
Exactly. So the credentials are stored, as mentioned, in AgentCore Identity, which is the same system that's going to handle all of the authentication for the agent. It handles the auth and token lifecycle. And so in just a few clicks, you are ready to securely transact with this agent.
Yeah, and one thing I would like to add is like once the credentials are stored, then we have a token which is provided by the service provider, either Coinbase or Stripe, and those tokens are short-lived, and we kind of refreshing that token and use that token to make the wallet operation. So we never touch the credentials again. We use that token which is short-lived, even if it is got compromised, that's fine. Like like we kind of refreshing that token, and we are ensuring that all the wallet operations are happening through that short-lived token. So added like additional layer of like security and extra layer of governance.
Yep.
And I see that you also have roles there, right? So essentially, like you have IAM controls on who can access this resource as well.
Yeah, and we'll cover a little bit more of that as we get deeper. But there's a clear IAM role separation between the agent and the management layer. So next we're going to talk about, so the other aspect we heard from developers many times is the idea that we want to control agent behavior and avoid any runaway spending, right? So how do we enforce our spending governance while orchestrating payments across all these protocols? And this has implications for regulatory obligations. We want to stop an agent from draining funds. We want to avoid overspending. We want to avoid the agent having access to sensitive credentials. And so what we do is we keep the user in control. The challenge here of a sort of a runaway agent, the solution is around a 3-phase commit protocol, and budget limits are never exceeded, right? So every process payment goes through this sort of 3-phase transaction workflow where the agent can create a wallet. Agent developer creates a self-custody for each user. The user delegates that permission through a signing delegation process to allow the agent to sign transactions. To use it, the user controls the top up of the wallet. They log into their Coinbase and Stripe portal, as mentioned before, and they can use a different variety of mechanisms to fund the wallet using stablecoins or fiat methods. And then the user tops up and withdraws the funds out of band. So the agent is able to spend on the behalf of the user's self-custodial wallet with explicit delegation permission.
So what you're showing is also the permissions over there, right? So what about these budget enforcements, right? So what about that?
Yeah, so this budget enforcement, because of this 3-phase commit, we have this atomic enforcement, right, with compensating rollback. So even under concurrent load from multiple agents, the budget limits are never exceeded, right? So we have these atomic conditional checks to eliminate any race conditions. And every process payment call goes through this sort of 3-phase transaction workflow, where the available spending limit is reserved by deducting the requested amount atomically, and then the payments processed through the provider. And then the transaction's committed on success or rollback on failure, which will restore the reserved amount to the available balance. And this is done to make sure that whether it's a single agent or thousands of agents transacting against the same budget, we never encounter any stale reads, overwrites, and we don't have an overspending problem.
This is definitely, if you don't have these kind of controls, it's going to be a risk because you could use the same authorization to make multiple transactions with the agent, right? So good to see that this is all baked in.
Yep, exactly. So a payment instrument, as we discussed before, is the wallet that belongs to an end user. So the backend creates it when they onboard, they fund it, and they grant that delegation, that signing consent. And from then on, your agents can pay on behalf of the user within the guardrails that you've set. The transaction traces back to the user that has full attribution for audit, compliance, traceability. So a payment method, typically a crypto wallet address that belongs to this end user, is created by the application backend per user. So the user signs up and they opt into payments. The developer is going to provide a payment manager ARN, which is which manager, right? The payment connector ID, which indicates the provider, as we showed before, Coinbase or the Stripe Privy Wallet, and a payment instrument type, right? So for crypto, this is going to be an embedded crypto wallet, and then details around the network. And AgentCore is going to give back a payment instrument ID and a wallet address. And payment sessions are used within the context of all this to scope the payment context and track that spending against the transaction, right? So we have the instrument, which is the wallet itself, and then we have the session, which controls the budget and expiration. So we have time boundaries and spending boundaries that are in place. So spending limits and session expiration.
So what you're saying, Josh, is that we can set some boundary conditions on allowing the agents to make payments, right? So one of them is amount and the duration as well. Is that what I heard?
That's right. That's right. Those two controls there.
Cool.
That's awesome. That means that when a payment session expires per these conditions that you set, that payment session is automatically terminated, and the developer doesn't need to manage that payment session that is associated with an agent.
Exactly. And one thing we really designed for here, you don't want to just kind of have faith in this agent to say, don't spend more than, $5, right? These undeterministic behavior. We want to take that sort of expiration, budget, limits, and we want to move those into the developer's control outside of the agent.
Okay, I'll move on.
That's awesome. Thanks, Joshua. Why don't we see some notebooks and code? I think we've seen enough of the presentation. Why don't we get into the weeds of how that looks like for an agent? How can we fund a wallet?
Yes, exactly. So I'm going to go ahead and share my screen. And first, I want to give some context. So we have this under AWS Labs on GitHub. We have a repository of AWS samples. We'll share all these links as well. And under Bedrock AgentCore samples has a whole collection of folders here with different types of helpful areas, right? Different use cases, integrations. We're going to highlight a couple of these today. So 01 features here, this has preset scripts and code to get you started. And then workshops, module 06 here, has notebooks that can be run as sort of a training exercise and to learn as a tutorial or to present in a workshop capacity. So if we click through this, you'll see here we have one for each service within AgentCore with tools, observability, runtime, our new harness, and payments. So we click into payments. And this is the core repository for the samples for all the notebooks for AgentCore payments. So I'm going to be looking in here today and walking through some of this. There's a collection of folders here that have different tutorials. So if I move over to, I have a Jupyter Lab notebook set up here locally on my computer where I've loaded those same folders that I just showed. So I've loaded those here into my lab. And then I'm going to be talking about this user onboarding. So we've already done this prerequisite. We've set up the payment manager and the connector. And we're going to focus on this user onboarding, right, per end user. This will create the wallet, fund it, delegate the signing, and provision wallets. So there's a couple of prerequisites here. And then we have the onboarding flow, right? So the developer creates the payment instrument and the wallet address, and then the wallet info will be shared to the end user, which can fund the wallet and grant the signing permission. And then once the delegation is registered, then the session can be created and the agent can start paying. So you see here the ability to create an embedded wallet. See here, new instrument created, fund the wallet. So it depends on different workflows for different providers. So Coinbase versus Stripe examples in the notebook. And then we do the signing permission, right? So under here, we have the workflows shown, right? For Stripe Privy as a provider and Coinbase, and you'll see the on-ramp and the signing delegation for each, which varies.
Absolutely. And there are different types of end user flows that you can do for both the wallet providers. And we also have some getting started examples and provider notebooks for these setups that you need to do one time on the respective portals for Coinbase and Stripe Privy. And once you have those setup notebooks, you're able to choose the wallet provider of your choice, or in fact, choose both the wallet providers for your agent. And as we learned earlier, you're able to have multiple connectors within a manager. So feel free to experiment variety of combinations possible for your agents.
Yeah, we actually mentioned that we have inside of our setup, we also have a multi-provider setup notebook here as well. So we have a lot of different types of resources available for all of these different configurations.
Yeah, one thing I would like to add is the agent developer creates a wallet on behalf of the end user. So it's a self-custodial wallet, which means the end user is the owner of the wallet. So they have full control of when to top up funds, when to withdraw funds, and they have to give an explicit delegation as a one-time activity for the agent to go and spend on their behalf for their self-custodial wallet. That's a very important piece which we're trying to kind of show here. So the end user is always in control. They can withdraw funds anytime they want. And the developer creates that wallet on behalf of the end user. And once they give the delegation, then the agent can go and spend on behalf of the end user.
So Chetan, just like how we can give the permission, can the end user also withdraw the permission and remove that as well?
Yeah. So they can also remove, and they can withdraw the funds as well, right? In which case the agent can't go and spend it. So the end user is always in the control. Even developer is not actually in the funds flow. That's an important thing, right? The wallet is technically owned by the end user, and developer just facilitates that for their end user, and then agent goes and spends it on behalf of the end user. So even the developer on either AWS falls in like the funds flow.
Yep. I also just want to quickly show, we talk about these runaway funds, we talk about session and budget limits. We also have a notebook here that shows how to enable payment limits using a real Strands agent. So this shows using the payments SDK with Strands agents and deploys an agent with a session and budget. So if we look through this notebook, you see we have the same we have a Coinbase provider here. We've got our payment instrument set up. And then we create the Strands agent using the Strands plugin. And we have a happy path here where it went and checked, it says access paid weather API, go take a look, give me the weather, it pays for it. But then we can set sessions and budgets, right? So we have a budget here, 60 minutes, 50 cents. We update it. It goes and gets the weather. And then it says, I use 1/10 of a penny here. I have 0.499 left. And critically, we're going to set a session with a very tiny budget, right? 0.0001. That means that any money we spend will be above the budget. And so we want that to hit a wall. And you'll see here the error comes back, insufficient budget, right? And this is not the agent making a decision around, oh, I can't spend more money than this, right? This is a hard control in place.
So that's important to know, right? Because agents, if they think about ways of doing this, skills can be poisoned, various things can happen. But here we have those hard controls that do not allow the agent to transact beyond what was said.
Right.
Yeah.
Absolutely. And this is what it unlocks, right? And the beauty of it is for AgentCore payments, developer ease is at the core of it all. And you can build these local agents with Strands agents, LangGraph, or any other popular open source frameworks, and use any model as well. But with Strands Agents SDK, we've also launched a payment plugin that Joshua shared, and we can share more documentation on how you saw that you just had to write few lines of code to provide all of these capabilities within your agent's code. So you really make it much and much simple to build agents with AgentCore instance. So the next question, I think, in the series of questions developers have comes, which protocol should I pick? How does that affect once I invested developer months into building an agent? And to address this developer challenge, AgentCore Payments is designed to be in a protocol agnostic way. The control plane and the data plane APIs that you do one time it will remain the same, even if downstream you decide to change to another protocol. Today, in public preview, AgentCore Payments supports the X402 payment protocol, which is an open neutral standards for internet-native payments. So what does that really mean for autonomous agents, as Chetan really showcased that? What it does, X402, is it uses the HTTP's native payment standard that repurposes the HTTP 402 status code for direct and programmatic payments. This unlocks a whole new realm of agentic workloads where you agents are able to autonomously make payments, which connects these buyers and merchants together with AgentCore Payments right in the center to for agents to access these paid endpoints. And how do we do that is with the help of a payment orchestrator engine. So we've been talking about the fact that AgentCore Payments is a managed service for payments, but really let's dive deep under the hood on what it manages for you. For any developer, ramping up on any single protocol, as we've seen in over the last years, is not just for payments, right? Like agentic protocols and open standards are continuously evolving, and this is a fragmented landscape which comes with its own nuances of different versions, different authentication flows, and different transaction models. And developers must understand all of this to build anything to even get started. And beyond the protocol selection and detection, developers must also construct this abstraction layer that gets the right input fields from those payment loads and manage any such changes that they need to make per protocol, or tomorrow there could be a complete new protocol, Chetan, and that changes the agent code as well. And as we saw that integrating payment limit and budget enforcement should be beyond an LLM decision where it's not just the model and the agent making a decision, but having a purpose-built infrastructure within your API structure that addresses whether the limit is being reached or not. For microtransactions on execution on different networks, this orchestrator engine also resolves the different networks. That means you could fund these wallets and execute payments on not just one network. You could have that on Ethereum, Solana, and in the future, other networks as well. And once you have this, once you've resolved this network specific transaction data, you need to sign the transaction, generate the proof, and present it back to your agent. All of this happens with a single process payment API, and this is the core of AgentCore Payments. It's orchestrated in a pluggable model where for each payment protocol and provider, the implementation is the same. You can choose the wallet provider API of your choice, and adding a new support for a new protocol doesn't really change your entire agent logic. And this process payment API is the API to sign that transaction and send this paid endpoint for your agent to access the paid endpoint contract. And what does this really abstract is something we will dive deeper into. So if you see with and without the service, this is what we really manage for you. An agent developer building this capability needs to plumb all these different payment providers, build the integration of different protocols and the different networks on which these on-chain executions attract. And this scales compounded in a compounded fashion. And with AgentCore Payments, all of this is abstracted away in a single API. So this is the entire end-to-end flow, as we saw, that executes within the payment orchestration engine when a tool is invoked by an AI agent that needs a content. What the X402 protocol enforces is a payment required HTTP 402 within the payload response. It's going to check for the payment limit within its active sessions. That means if the session is already stale, it automatically rollbacks and does not allow the agent to do. If it passes that check, it signs that payments, it retrieves the wallet credentials from AgentCore identity. So at an infrastructure layer, your authentication credentials and your payment limit checks are deterministically enforced with secure credential management. It retries with the correct signed payment payload within the X payment header, verifies and settles it on the merchant. The merchant verifies that payment proof, and the transaction is completed and the status is updated. This end-to-end workflow happens with proper IAM role segregation model. We have documentation on that as well. So Joshua, why don't we take a look at the notebook that completes an agent, not just a local example, but a real agent on scale with session isolation on AgentCore runtime. How does that work?
Yeah, so thanks, Manu. So this same notebook that I've got open, we also have a sample around deploying a payment agent to AgentCore runtime. So as you mentioned, this is a scalable reference where we show how to actually deploy the agent into runtime, and we have provided some code for the payment agent as well. So we have these patterns here. We have this Bedrock AgentCore app with an app entry point, right? So service contract to run on runtime, and it's all stateless, right? So what we do is if we go down here, I'll just jump to, there's some local tests here, and then we scaffold out the project and deploy to runtime. So you'll see here, it's deployed, and then we want to invoke. So when we look at the process, you talked about the process payment and how it actually works, right? So on the back end, we're going to call an invoke against the agent. We're going to call that the AgentCore runtime. Our agent that's running on runtime is going to make that HTTP request out to the paid endpoint, and the 402 is going to come back. That's when process payment gets called, right? So it's indicating that it needs that 402, and then it's going to execute that process payment API from the agent. Once it gets the payment proof back from AgentCore payments, it's going to send that X payment header with all that proof of payment back to the paid endpoint, and then receive the data back with the 200 header. And then the result will come back from that AgentCore runtime back to that backend. And I can quickly show as well the payment agent. So this is also inside the sample. And so you'll see here, if I look at the code, you'll see that app entry point here as well with all the agent code.
Yeah. And if you're familiar with AgentCore runtime as well and the AgentCore SDK, we make it very, very simple to take your local agent experiment, host it scalable on runtime. You just need to add 4 lines of code. That's app.entrypoint, Bedrock AgentCore app, initiate the app.run, and you're able to transform a simple local experiment into a scalable agent on runtime with proper role segregation on who can make the payment, who has the control to the app backend, and how the entire plugin flow is managed and controlled.
And we've shared the Strands example, right? So Strands framework example. Just want to know about other frameworks like LangChain, or if I want to get LangGraph.
Yeah, absolutely. In the agents payment 01 folder, we have an example of a Strands agent. We also have an example of a LangGraph agent, and more coming soon. Awesome. So we're talking about agents so far on the agent developer side. Let's shift our focus to the other side, which is these paid merchants, right? So Joshua, what is going on in the merchant side? How do we discover these paid endpoints? And if I'm completely new, how do I get started?
Yeah, so this is a landscape that's just continually evolving, right? And one of the things we wanted to do for our developers is let our service sort of scale with the ecosystem growth and have this automatically available to developers. So we partnered with Coinbase here on their X402 Bazaar and connected into it, right? So AgentCore Gateway is our service that allows you to connect out to MCP servers and API endpoints and make sure your agents have secure access to them. And with AgentCore payments, we're allowing this to extend out to paid API endpoints and MCP servers. And so you can leverage the pre-existing integration that we've built out with Coinbase X402 Bazaar through AgentCore Gateway to discover thousands of tools. And if you look at like X42 Bazaar, to just go a little deeper into that, this is the discovery layer for X402 built by Coinbase and cataloged through their facilitator service that manages the transactions. So this indexes a bunch of payable API endpoints, provides semantic search descriptions, metadata, and trust signals based on activity going to these endpoints. And so it surfaces this sort of single place to find and evaluate those endpoints.
So in short, if you're a developer that's building applications to monetize, submit them through the process to the Bazaar, right? So, and make the endpoints discoverable for the agents to transact.
Yep. And actually, when you facilitate a transaction through Coinbase's X42 service, right? So the payment, your agent makes a payment, the merchant chooses to facilitate that transaction that way. It will actually catalog itself into Bazaar. So this ecosystem is growing very rapidly. So if I just show my screen again here, I was just going to quickly go through. So I'm still on this payment screen from earlier, but I'm going to pivot over to gateways. So we're on now the home page for AgentCore Gateway. And it says to use tools within your agent, create a gateway to manage MCP and HTTP targets. So we go to create gateway, and we'll just leave all the defaults here for permissions. And we'll say we'll use JOT tokens, default. And then you'll see here there's this target type. And one of these selections is pre-configured templates from integration providers. And if I select this drop down, you'll see Coinbase X42 Bazaar is one of the defaults here. So this is ready to go out of the box. So once you create this gateway, connect your agent to it, you'll have access to that whole ecosystem.
And this is just one way by which we can access paid endpoints. And in our repository, we have various examples and tutorials and end-to-end use cases that showcases different ways in which agents can access paid endpoints. But thank you for showing how AgentCore Gateway also makes it easy to access these paid endpoints. So moving on, we're seeing a lot of agents. We're seeing on how we can connect to paid endpoints. But the real question that Chetan asked in the start is, how do I really monitor end-to-end between my agent, between my tools, between these payment providers and identity providers? How do I really audit how my agent is spending and really measure the success of adding these capabilities to my agent? With AgentCore Payments and AgentCore Observability, it delivers a three-pillared observability system that automatically emits metrics, logs, and traces. Like the rest of the AgentCore services, it enables vended logs, CloudWatch metrics, and distributed traces that not only give you insights into what your agent is doing, but also insights into AgentCore Payments-related information. And what does that mean? Is success and failure counts, latency associated with the payment APIs, spend amounts, different resource ARNs, and the request IDs associated. So you as a developer adding these capabilities can now track where your agents are spending by different operations, and structured logs are delivered carrying these different IDs and information. So you're able to audit end-to-end what's going on. With AgentCore Observability, you also have distributed traces. With distributed tracing, the beauty is you're able to stitch these open telemetry spans together and correlate that to your agent workflows. And we'll quickly see how that is possible in a demo just next. But what this really unlocks for you is not just seeing how things are going, but really quickly identifying when things go wrong. Because with AgentCore Observability, you're able to connect AgentCore Payments to the rest of the AgentCore services and across different blockchain networks related to different protocols and wallet providers. You're also able to see full end-to-end visibility into the different other AgentCore services that you use, which could be AgentCore browser tools, code interpreter tools for financial analysis, AgentCore Gateway to integrate with Bazaar, or other AgentCore services as the service expands to access these paid content.
Yeah, I know we have like 5 more minutes. Do you think we can take a quick sneak peek into the observability dashboards and see how that looks?
Yeah, so why don't we look at an end-to-end use case of a research agent that has access to financial paid endpoints and see a complete execution of an agent making financial analysis.
Yeah, that will be awesome.
Yeah. So I'm back at the AgentCore homepage here, and I just want to call out. So I'm going to click on this observability section here, and this is going to open a new tab, which I've got open. So AgentCore observability provides, when you go right into when you land on the observability page, you've got this sort of filter here. So I can click on payments, and this will show me this overall dashboard, right? So if I look at custom, I say, show me the last few weeks. I've got, agents using payments. I've got lots of transactions. And then if I go into details, you'll see there's a bunch of out-of-the-box dashboards in terms of how many agents do I have using payments, look at my payment sessions, transaction error rates.
So you're able to monitor all things that your payments that are created on this account, and not just per your agents. How many agents are using those payments, how many transactions are really happening, and the API invocation all out of the box once you enable vendor logs and metrics on your agent. So let's take a deeper dive into the details of what a particular trace would look like for a successful execution. Or
yeah, so I switched over to traces here. Oh, sorry.
Yeah, or an unsuccessful one. How do I really debug and audit everything?
Yeah, I was going to pull up a trace here that I ran. This is a research agent, as you mentioned, with a code interpreter. And so this is going to go out, and this is based on one of our samples that we have. I can quickly show. So we have this pay for data example that connects and analyzes SEC filings, macro indicators, and uses AgentCore code interpreter. And so I ran this. If I look at just the agent spans, you see sort of this view here where it shows the spans for the agent. But I can clear this, and then you get this huge zoomed out view that traces the entire transaction lifecycle and all of the calls across the agent payment flow as well as outside of the payment. And if you look here, I've got this span error surfaced. It looks like this particular session got an access denied issue for authorization. There's a missing permission here on code interpreter call. But the point is I can debug this, and I can surface this in the same span and trace as the payment workflow itself in the transactions.
And this is the real power of AgentCore observability, where you're able to stitch agent telemetry that is emitted by the framework and stitch it together with AgentCore service telemetry, which could be different service telemetry from runtime, code interpreter, gateways, memory, or something wrong, and easily point out what's going wrong. Because in your agent invocation, when you just see the agent hallucinating, you really don't know what's going wrong. Is it an IAM permission issue? Is it a tool issue? Is my wallet not having funds?
Exactly. Yeah.
There's so many questions we have gone through, and this out of the box is easily able to provide an answer to the developer. Is sitting out there debugging this.
Right, so we've seen a lot today, right? So agents making transactions and making the agentic economy possible, right? So I think that's the next step in agents evolution, right? So any takeaway for our viewers as we wrap up the session?
Yeah, so Chetan will be sharing some of the resources we have. We have various GitHub samples for getting started. Go through the AgentCore payments documentation, build your own examples for agents that can transact. We have paid scripts on the features folder, notebooks for guided analysis, guided notebooks, and technical deep dive blogs as well.
Yeah. And before we wrap, I think I just want to give us quick sneak peek on what's coming. I think microtransactions where we start, which is where like agents going making transactions for paid APIs, paid MCPs, and content. But there are other use cases also, right? There is like traditional commerce use cases, which we are kind of working on. So there is more to come. And would love to for developers to try this solution and provide us feedback. And try out to unlock their use cases.
Cool, folks. Thanks for joining the live stream and sharing a deep dive. on AgentCore payments and how agents can interact and make transactions on behalf of users. Right. So that's it from our side today. It's a wrap. We'll see you next week for another live stream.
Thank you so much,
Thank
Anna.
you, everyone. Thank you.
Thank you. Bye all.